What is a Chinook?
A Chinook, sometimes called a snow eater because it melts snows, is a wind that is generally warm and originates from the eastern slope of the Rocky Mountains. It often moves from the southwest in a downslope manner, causing a noticeable rise in temperature that helps to warm the plains just east of the Rocky Mountains.
What types of psychrometers are there?
Old-style sling psychrometers are made from two thermometers secured to metal that is allowed to hang for a number of minutes until the wet bulb begins to cool. More modern psychrometers use a variety of sensors, including the use of chemicals that change their electrical conductivity due to humidity levels.
How are supercooled droplets used for the purpose of cloud seeding?
Cloud seeding is a method for encouraging rain droplets to form in clouds. An experiment was conducted in 1946 by chemist and meteorologist Vincent Schaefer, 1906 to 1993, and physicist, chemist, and Nobel laureate Irving Langmuir, 1881 to 1957, in which dry ice, frozen carbon dioxide, at -109 degrees Fahrenheit -78 degrees Celsius was placed inside a cloud chamber containing cloud droplets chilled to -40 degrees Fahrenheit -40 degrees Celsius. The result was that rain droplets formed. The next step was to conduct the experiment in a real-life situation. In the winter of 1946, Schaefer and Langmuir had dry ice placed in an airplane, which then dumped the load into a bank of stratocumulus clouds. They were pleased to see success when the dry ice caused a snow flurry to develop. American physicist Bernard Vonnegut, 1914 to 1997, who also worked with Schaefer, later experimented with other chemicals to see what else would be an effective way to seed clouds. He found that silver iodide, which is still used today, could perform the task well. Since then, other substances have been used to seed clouds, including sea salt and even water droplets. However, all these methods appear to work best in the winter. During warmer months, seeding clouds has proved to be more problematic, because the correct conditions to produce precipitation are less common.
What are some disturbing statistics regarding air pollution in Egypt?
The World Health Organization estimated that breathing the air in Cairo, Egypt, is the toxic equivalent of smoking 20 cigarettes every day. Damage to the Egyptian economy as a result of pollution is also troubling, with the World Bank noting in 2002 that 5% of the country's gross domestic product, or about $2.42 billion US, are lost annually due to damages attributed to pollution.
What month is known for the most extreme changes in temperature?
July holds the honor for most extreme variations of temperature globally. Record extremes on the planet occurred when measuring the temperature in Libya versus the temperature at the South Pole. The difference between the two was 265 degrees Fahrenheit 129.4 degrees Celsius.
What key event brought the issue of acid rain to prominence?
During the 1960s, fish began to die in Scandinavian lakes at an alarming rate. When investigated, it was found that the lake water had become so acidic as to be unlivable for many species. The source of the acid was European industrial emissions creating acid rain and snow. Further research found that lakes in the United States, Canada, and other nations were suffering the same fate.
What are equinoxes and when do they happen?
An equinox is a time of the year when, in the course of Earth's orbit, our planet is at a location where the equatorial plane and the ecliptic plane intersect. In other words, the tilt of Earth's axis is pointed perpendicular to the line between Earth and the Sun at an equinox. Earth's poles are tilted neither toward nor away from the Sun, but tilted off to the side. On the day of an equinox, there are as many minutes of daylight as there are of night, hence the term equinox, meaning equal darkness. In the northern hemisphere, the vernal, spring, equinox occurs around March 21st of each year. And the autumnal, fall, equinox occurs around September 21st.
What is universal coordinated time?
Meteorologists, as well as many other scientists, use the standard of universal coordinated time, UTC, as a time reference to coordinate their measurements. Also known as Greenwich Mean Time, GMT, because Greenwich, England, is the place where the standard time is set. As well as Zulu or Z time, UTC employs the 24-hour clock also used by the military. Thus, 0000 UTC indicates midnight and 1200 UTC is noon. A standard set by meteorologists is to make observations every 6 hours at 0000, 0600, 1200 and 1800 UTC.
What is a geomagnetic storm?
A geomagnetic storm is the term used for a strong increase in solar wind activity, including intense X-rays that affects the Earth's magnetic field.
What is a hydrometer?
A hydrometer measures the specific gravity of a liquid. It is used to determine the density of a fluid compared to the density of pure water at 60 degrees Fahrenheit 15.5 degrees Celsius. This can be handy when seeking a reading for the salinity of water, such as when taking samples of sea water.
What are cosmic rays?
Cosmic rays are invisible, high-energy particles that constantly bombard Earth from all directions. Most cosmic rays are protons moving at extremely high speeds. But they can be atomic nuclei of any known element. They enter Earth's atmosphere at velocities of 90% the speed of light or more.
When do thunderstorms occur?
In the United States, thunderstorms usually occur in the summertime, especially from May through August. Thunderstorms tend to occur in late spring and summer, when large amounts of tropical maritime air move across the United States. Storms usually develop when the surface air is heated the most from the sun, 2 to 4 p.m. Thunderstorms are relatively rare only in far northern and coastal New England, as well as along the Pacific coast. Florida, the Gulf states, and the southeastern states tend to have the most storms, averaging 70 to 90 annually. The mountainous Southwest averages 50 to 70 storms annually. In the world, thunderstorms are most plentiful in the areas between latitude 35 degrees north and 35 degrees south. In these areas there can be as many as 3,200 storms within a 12-hour nighttime period. As many as 1,800 storms can occur at once throughout the world. Lightning performs a vital function. It returns to the Earth much of the negative charge the Earth loses by leakage into the atmosphere. The annual death toll in the United States from lightning is greater than the annual death toll from tornadoes or hurricanes. 150 Americans die annually from lightning and 250 are injured.
What is an asteroid?
Asteroids are relatively small, compared to moons and planets, rocky objects in our solar system. They range in size from a few feet across to behemoths like Ceres, which is 580 miles, 933 kilometers, in diameter. The majority of asteroids can be found in the asteroid belt, a band of rocks orbiting between Mars and Jupiter. The origin of asteroids remains the subject of scientific study. Astronomers today think that most asteroids are planetesimals, that never quite combined with other bodies to form planets. Some asteroids, on the other hand, may be the shattered remains of planets or protoplanets that suffered huge collisions and broke into pieces. Asteroids range in composition from rubble piles that are loose collections of rock held together by gravity, e.g., the Mathilde asteroid, to solid rock, Eros, to asteroids with high metallic content, Cleopatra. Some asteroids are so large that they exert gravitation and have tiny moons orbiting them.
What are thermographs and hygrothermographs?
A thermograph is a device that records changes in temperature over time by drawing a line over a rotating chart in a manner similar to a seismograph. A hygrothermograph does the same thing, except it also indicates levels of humidity.
How is the ionosphere important in the transmission of radio waves?
When ultraviolet light enters the atmosphere, it ionizes atoms in the ionosphere through a process called photoionization, which releases free electrons into this region of the atmosphere. It is these free electrons that make radio wave transmissions possible. Depending on the frequency of the radio waves, transmissions travel for shorter or longer distances. Lower frequency waves bounce off the ionosphere at a lower elevation, and thus travel a shorter distance than higher frequency waves. Very high frequency waves are used when communicating with satellites or anything out in space because they can completely escape the atmosphere. British physicist Oliver Heaviside, 1850–1925, and American electrical engineer Arthur Edwin Kennelly, 1861–1939, independently theorized the existence of an ionosphere, and that certain wave frequencies would bounce off it and be reflected back to Earth. It was radio pioneer Guglielmo Marconi, 1874–1937, who first took advantage of this theory to conduct the first transmission from Cornwall, England, to Newfoundland in 1901. The waves became known as radio waves, and Marconi is credited as the inventor of the radio. The E region of the ionosphere was named after Kennelly and Heaviside to honor their work.
What is the order of the colors in a rainbow?
The colors in a rainbow are those of a light spectrum: red, orange, yellow, green, blue, indigo, and violet, with the warm colors, red, orange, yellow, on the outside, farthest from the ground, and the cool colors, blue, indigo, violet, closer to the ground.
How long a path do tornadoes typically make?
Most tornadoes actually have fairly brief lifespans. lasting less than an hour and often only several minutes or seconds. About 5 miles of travel can be expected from an average tornado. Of course, there have been much longer-lived tornadoes, such as one on March 18, 1925, which crossed 215 miles, 346 kilometers, of terrain.
What is Dalton's law?
English meteorologist John Dalton, 1766 to 1844, discovered that adding up the partial pressures of each gas in a gaseous mixture will equal the total pressure exerted by the mix of gases. Dalton's law was formulated in 1801.
What is a solar flare?
Solar flares are sudden, powerful explosions on the surface of the sun. They usually occur when large, powerful sunspots have their magnetic fields too tightly twisted and torqued by the hot, swirling plasma in the sun. The magnetic field lines unwind and break suddenly, and the matter and energy that had been contained rushes outward from the sun. Solar flares can be many thousands of miles long, and they can contain far more energy than all of the energy consumption of all of human history on Earth.
What was the world's worst nuclear disaster?
In April 1986, the Chernobyl nuclear power plant in the Ukraine, near the border with Belarus, had a major accident that released radiation into the atmosphere. The protective covering of the nuclear reactor exploded and deadly radiation escaped, immediately killing at least 28 people and giving 240 others radiation sickness, 19 of whom later died as a result. The radiation exposure that initially occurred is still killing people through related diseases, especially thyroid cancer, and this will continue for many years. More than 100,000 people were evacuated from the region, and deaths due to radiation poisoning continue as radioactive isotopes spread across Europe. The radiation cloud that resulted from the disaster traveled more than 1,300 miles. 2,000 kilometers, infecting crops and livestock that then became unsafe to eat.
Does the North Pole have the same average temperatures as the South Pole?
One might think that the northern and southern extremes of the planet would have comparable annual temperatures. In actuality, the South Pole is much colder. This is because giant glaciers have built up on the continent of Antarctica, where the South Pole is located. The inland ice sheets of Antarctica are 8,036 feet, 2,450 meters, thick on average. and this thick layer of ice keeps the South Pole about 50 degrees Fahrenheit 23.6 degrees Celsius colder than in the north.
What are some other unexpected places where it has snowed in the United States?
In Louisiana, 2 feet, 61 centimeters, of snow fell on the town of Rain on February 14, 1895. Another old record is held by Savannah, Georgia, where 18 inches, 46 centimeters, of the white stuff fell on January 10, 1800. More recently, residents of New Orleans were surprised to see snow accumulations on their front lawns on December 11, 2008.
What is the difference between the aurora borealis and the aurora australis?
The aurora borealis is the name for aurorae that appear in the northern hemisphere, while the aurora australis appears in the southern hemisphere.
What are solstices and when do they occur?
A solstice is a time of the year when Earth is pointed either the closest toward the sun or the farthest away from it. On the summer solstice, there are more minutes of daylight than there are on any other day of the year. On the winter solstice, there are fewer minutes of daylight than there are on any other day of the year. In the northern hemisphere, the summer solstice occurs around June 21st of each year, when the North Pole is pointed closest toward the sun, and the winter solstice occurs around December 21st of each year, when the North Pole is pointed farthest away from the sun.
Which Chinese scholar first hypothesized about climate change?
In the 11th century c. E. Chinese writer Shen Kuo, 1031 to 1095, noticed that bamboo plants were buried in the ground near Shanbei. This region was far too northerly for bamboo to grow in Shen's time, and he therefore reasoned that the climate there had once been very different.
Who first photographed a sprite?
In 1989, while experimenting with low-light video cameras for use in high-altitude rockets, University of Minnesota scientists Robert Nemzek, John Winkler, and Robert Franz accidentally captured images of sprites. This quickly piqued the interest of NASA scientists at the Marshall Space Flight Center in Huntsville, Alabama, who managed to record more examples of sprites. Later successes of taking pictures or video of sprites came from Walter Lyons, who filmed over 240 sprites on July 7, 1993, and Dave Asintman and Eugene Westcott of the University of Alaska. who used a NASA aircraft to film sprites that same month.
When were huge snowflakes observed?
In January 28, 1887, in Ft. Kia, Montana, there was a snowfall that included flakes measuring a spectacular 15 inches. 38.1 centimeters, across. Of course, these flakes were not individual crystals, but rather clumps of crystals sticking together to form large flakes. Not long after these stunning flakes were seen, Shire Newton, England, experienced a storm in 1888 where 3.75-inch, 9.5 centimeter, snowflakes were seen.
What is the Milankovitch cycle?
Earth's orbit is currently fairly circular around the Sun. However, this is not always the case. Our planet experiences shifts from the current circular orbit to a much more elliptical one, during which the difference between perihelion and aphelion is very marked. The entire cycle from circular to elliptical and back again takes about 95,000 years to complete. During the periods when the Earth is in its more elliptical orbit and ventures farther from the Sun, ice ages tend to occur. The theory was first formulated by Serbian geophysicist Milutin Milanković, also spelled Milankovitch, 1879–1958, who was well known for his research into ice ages. His theories were later verified, in 1976. Through the study of sediment cores taken during deep-sea explorations.
What is agricultural forecasting?
Agricultural forecasting concerns itself with predicting weather conditions, especially hail, that can be hazardous to crops, including precipitation, especially hail, extreme hot and cold, and damaging winds. Accurate forecasting in this area is a particular boon to farmers in that meteorologists can help them decide when it is best to harvest or plant, when wind conditions are right to apply pesticides and herbicides, when to set up irrigation systems, or when to turn on wind machines and smudge pots before an oncoming freeze.
What effect does solar activity have on life here on Earth?
Why the time the solar wind reaches the distance of Earth's orbit, its density is only a handful of particles per cubic inch. Even so, it is enough to have caused substantial radiation damage to life on Earth over the several billion years of Earth's history, if not for Earth's protective magnetosphere. When solar activity is particularly strong, such as during a solar flare. The stream of charged particles can increase dramatically. In that case, these ions can strike molecules in the upper atmosphere, causing them to glow. Those eerie, shimmering lights are called the aurora borealis. Northern lights, and aurora australis, southern lights. During this time, Earth's magnetic field can temporarily weaken, causing our atmosphere to expand. This can affect the motion of satellites in high Earth orbit. In extremely strong periods of solar flux, electrical power grids can be affected.
How much of the Earth was covered in ice during the various ice ages?
Because of extensive erosion, it is difficult to determine the extent of ice sheets during the various ice ages. But scientists do know some things about the last ice age, the Pleistocene Ice Age, a time when up to 10% of the Earth was covered, although not simultaneously, by often miles-high ice. At their greatest extent, the Northern Hemisphere glaciers and ice sheets covered most of Canada, all of New England, much of the upper Midwest, large areas of Alaska, most of Greenland, Iceland, Svalbard, and other Arctic islands, Scandinavia, much of Great Britain and Ireland, and the northwestern part of the former Soviet Union. In the southern hemisphere, glaciers were much smaller, with the main effects being cooler and much drier weather. During the last stage of the Ice Age, the Wisconsin stage in the United States, ice sheets covered parts of Eurasia and much of North America, extending as far south as Pennsylvania. As the climate warmed up, scientists estimate that sea level rose about 410 feet. 125 meters, an average rate of an inch, 2.5 centimeters, per year for roughly 5,000 years. Interestingly, although most of the huge northern ice sheets melted, the Antarctic ice sheet decreased by only 10%.
Are there any circumstances where air pollution could be beneficial?
Yes. In fact, dust storms and volcanic ash can be a means for nature to distribute soils across the surface of the planet to regions that might not otherwise get certain nutrients. For instance, the Amazon rainforest may be famous for its verdant plant life, but in actuality the soil beneath the dense canopies is of very poor quality. Dust blown across the ocean from Africa to South America may help fertilize the rainforests. Not only that, but such storms bring nutrients to plankton in the ocean, which form the basis for aquatic food chains.
How loud is thunder?
A clap of thunder can be as loud as 120 decibels, abbreviated dBA. which is as loud as the noise at a rock concert, a chainsaw, or a pneumatic drill.
What is a dry front?
A dry front, also called a dry line or dew point front, is a borderline separating a mass of dry air from one of much more humid air. Often found east of the Rocky Mountains, these fronts will find the warmer, drier air lifting the cooler, more humid air ahead of it in the higher altitudes, while humid air near the ground is denser than the dry air and the drier air will flow over it. The result is an air mass reversal that can precipitate the formation of cumulonimbus clouds, thunderstorms, and, quite often, tornadoes.
What are glaze and rime?
Glaze, as one might infer, is the result of freezing rain or drizzle falling onto surfaces and forming a sheet of ice. Rime, on the other hand, is formed by freezing fog or mist during windy conditions. There are two types of rime, hard rime and soft rime. Soft rime has a milky appearance and forms sugar-like crystals shaped into scales, feathers, or needles on the windward side of thin objects such wires, poles, and tree branches. Hard rime is less milky, comb-like in appearance. It is also more dense and less fragile than soft rime. Hard rime can form in windy weather when the temperature is between 18 to 28 degrees Fahrenheit, -2 to -8 degrees Celsius, and humidity is 90% or more. While soft rime can occur in similar conditions, but when the temperature is below 18 degrees Fahrenheit -2 degrees Celsius.
Can weather be predicted from the stripes on a woolly bear caterpillar?
It is an old superstition that the severity of the coming winter can be predicted by the width of the brown bands or stripes around the woolly bear caterpillar in the autumn. If the brown bands are wide, says the superstition, the winter will be mild. But if the brown bands are narrow, a rough winter is foretold. Studies at the American Museum of Natural History in New York failed to show any connection between the weather and the caterpillar's stripes. This belief is only a superstition, it has no basis in scientific fact.
Is the National Aeronautics and Space Administration, NASA, involved in weather forecasting?
Since NASA is involved in implementing weather satellites, it obviously is very much involved in weather forecasting. NASA doesn't only concern itself with sending out manned and unmanned missions into the solar system and beyond. It also spends a lot of time observing the Earth. Weather and Earth science satellites gather information about changes in the climate, land use, and in our oceans.
What is the difference between perihelion and aphelion?
Perihelion is the point where the Earth is closest to the Sun. 91.4 million miles, or 147 million kilometers. This occurs around January 3 every year. Aphelion is when our planet reaches its farthest point from the Sun, 94.5 million miles, or 152 million kilometers. Around July 4. This variation does not have much effect on weather patterns or seasons.
What are atmospheric teleconnections?
Atmospheric teleconnections refers to the way that conditions in the oceans, including such phenomena as El Niño, La Niña, and ocean currents, interact with and affect the weather.
How does weather affect Earth's rotation?
Imagine the water, clouds, and other gases lying on top of the Earth's crust as a big soupy mass that can shift around as the planet rotates on its axis and is tugged on by the Moon, Sun, and other planets. The oceans and atmosphere slosh around due to tidal action, bulging a bit on one side or the other, and this can hamper or speed up the planet's motion. In comparison to the total weight of our planet, the liquids and gases are fairly light. But the inertia they experience does, in fact, change Earth's speed. The amount of change is not noticeable to us, a few thousandths of a second each year. Over millions of years, however, this has a cumulative effect.
What ancient Chinese book first discussed the idea of solar winds?
Although the Chinese discussed the idea of energy from the sun in terms of the notion of qi energy, the Book of Jin observed back in 635 c. That comet tails always pointed away from the sun. The unknown author understood that this was the result not of wind in our atmosphere, but rather from energy emitted by the sun itself.
What is a banjo barometer?
The banjo barometer is a barometer set into a banjo-shaped case. It was developed by Robert Hooke, 1635 to 1703, and was a very popular design because the large dial was easy to read and was large enough so that you could get very detailed readings.
What are northers?
Also known as blue northers. These are cold winds that blow southward from the Texas plains down to the Gulf of Mexico.
What is the lowest temperature possible?
According to physics, the lowest temperature possible is 0 degrees Kelvin. Minus 459.67 degrees Fahrenheit or minus 273.15 degrees Celsius, which is also known as absolute zero. This is the temperature at which molecular activity stops, and it is not possible for any more heat energy to be lost. Such an extreme, of course, does not exist naturally on Earth, except in some university laboratories. The lowest air temperatures can go on the planet is about minus 130 degrees Fahrenheit, minus 90 degrees Celsius. An unverified reading of minus 132 degrees Fahrenheit, minus 91 degrees Celsius was reported at Vostok, Antarctica, in 1997.
Is there such a thing as a meteor?
Yes. Meteors are not hailstones because they don't form in clouds the way hailstones do. They are giant ice stones that do not require thunderstorms in order to form. Meteors range in size from about a third of a pound, half a kilogram, to a monstrous one found in Brazil that weighed 137 pounds, 62 kilograms.
When did modern weather forecasting begin?
On May 14, 1692, a weekly newspaper, a collection for the improvement of husbandry and trade, gave a 7-day table with pressure and wind readings for the comparable dates of the previous year. Readers were expected to make up their own forecasts from the data. Other journals soon followed with their own weather features. In 1771, a new journal called the Monthly Weather Paper was completely devoted to weather prediction. In 1861, the British Meteorological Office began issuing daily weather forecasts. The first broadcast of weather forecasts was done by the University of Wisconsin Station 9XM at Madison, Wisconsin, on January 3, 1921.
What else does too much sun do to one's skin?
Besides increasing the risk of skin cancer, melanoma, sun exposure causes premature wrinkling of the skin and eye cataracts.
Can a hurricane be stopped?
For all practical purposes, no. Proposals have been suggested, such as cloud seeding techniques, but to date science has yet to come up with a solution. During the 1950s, the U.S. federal government launched the Storm Fury project, which was an effort to dump silver iodide crystals near the eyes of hurricanes. The theory was that the seeding would generate a secondary eye in the storm, which would then hamper or even cause the original eye to collapse. Several experiments were conducted in 1961, 1963, 1969, and 1971, but while sometimes the results seemed promising, the data was inconclusive. Hurricane Esther, in 1961, appeared to be weakened by as much as 30% through seeding. But there was no proof that the storm didn't just weaken all by itself. The government gave up the project in the 1970s, and while private companies have continued some of this research, most meteorologists believe that there is just no practical way to destroy a hurricane. The problem seems to be the fact that, for it to work, cloud seeding requires supercooled water. But hurricane clouds contain insufficient supercooled moisture.
What is the National Acid Precipitation Assessment Program, NAPAP?
Initiated by the Acid Precipitation Act of 1980. The NAPAP studied acid deposition throughout the United States. After 10 years, the researchers reported to Congress that while acid rain was a problem, the danger was not quite as severe as initially feared. About 4% of the lakes in the United States were deemed unacceptably acidic, and 25% of these lakes had acidic water due to natural causes. For example, decaying vegetation debris can raise water acidity levels.
What is a coronal mass ejection?
A coronal mass ejection is a huge blob of solar material, usually highly energetic plasma that is thrown outward into space in a huge solar surface explosion. Coronal mass ejections are associated with solar flares. But the two phenomena do not always occur together. When coronal mass ejections reach the space near Earth, artificial satellites can be damaged by the sudden electromagnetic surge caused by the flux of these charged particles.
Can you see the aurorae during the day?
No, human eyes can't detect aurorae during the daytime. However, the aurorae are there, and satellites that can detect X-rays, such as the POES, are able to monitor aurorae activity.
What was the Donora smog disaster of 1948?
One of the most shameful chapters in environmental history occurred on October 30 and 31, 1948, in the industrial town of Donora in Washington County, Pennsylvania. The 14,000 residents were mostly supported by steel mills, which found a location by the Monongahela River just 30 miles, 48 kilometers, from Pittsburgh to be ideal. The mills provided good-paying jobs, but the blast furnaces they used produced massive quantities of soot, sulfur dioxide, and other pollutants. In addition, the town was home to a zinc smelting plant and a sulfuric acid plant. As if that weren't enough, the natural climate of the town made foggy weather a regular occurrence. The industry combined with the weather during a horrible Halloween season in 1948, creating such thick brown air that it was nearly impossible to see where one was going. 500 of the residents fell ill from various respiratory problems and 22 people died. 17 from complications from asthma or heart disease, and 2 from tuberculosis aggravated by the filthy air.
Why is there an ozone hole at the South Pole but there isn't one at the North Pole?
The harmful chemicals that destroy the ozone layer have to be carried up into the stratosphere by clouds in order to react with ozone. The land mass at the South Pole, Antarctica, creates the necessary weather conditions for this to happen. While the North Pole is covered in water, causing winds in the upper atmosphere to blow away pollutants. The bad news is that some scientists fear that increasing levels of pollution may result in a hole in the ozone at the North Pole in about 20 years.
How strong does a tornado have to be considered significant?
Tornadoes that are F2 or stronger are generally considered to be significant in scale. F4 and F5 tornadoes are considered violent, and rightly so.
What is an aurora?
An aurora is a bright, colorful display of light in the night sky. Aurorae are produced when charged particles from the sun, usually solar wind particles, but sometimes coronal mass ejections as well, enter Earth's atmosphere. The particles are guided to the north and south magnetic poles by Earth's magnetic field. Along the way, these particles ionize some of the gas molecules they encounter by drawing away electrons from those molecules. When the ionized gas and their electrons recombine, they glow in distinctive colors, and the glowing gas undulates across the sky.
What other countries also have weather satellites in orbit?
Currently, the following countries have weather satellite programs: Japan, Russia, China, India, South Korea, and Europe, European Space Agency. Japan launched its geosynchronous meteorological satellite Himawari in 1995, but in 2003 it malfunctioned. And so NOAA permitted the Japan Meteorological Agency use of the older GOES-9 satellite. The European Organization for the Exploitation of Meteorological Satellites, EUMETSAT, operates what is now the second generation of Meteosat satellites. Europe launched its first weather satellite in 1995. And this second generation came online in 2004 with Meteosat 8. This satellite scans the entire globe every 15 minutes. China launched the Fenyun in 1990, and there have been several successors since then. That same year, Russia launched GOMS, Geosynchronous Operational Meteorological Satellite. The Indian satellite, INSAT, made orbit in 1990. And was used for both weather observations and communications. It was followed by INSAT 2 through INSAT 4 series, before the Kalpana 1 was operational. In 2002, the Kalpana 1 satellite is India's first exclusively meteorological satellite. South Korea's first weather satellite is the Communication, Ocean and Meteorological Satellite, COMS, which was launched in 2005.
What is eutrophication?
Eutrophication is the excessive buildup of nutrients in lakes, ponds, and other water bodies as a result of river and stream runoff containing pollution from fertilizer, sewage, and other waste products. While more nutrients in the water might at first sound like a good thing, it actually has harmful side effects, such as algae blooms that deplete water of oxygen and kill off aquatic species and other wildlife. Factory farms and private residents who fertilize their lawns are major culprits of this type of pollution. If you live by a fresh water source, such as a pond or stream, you can lessen the negative effects of runoff by creating a natural plant barrier between your lawn and the water. Among the plants that make ideal buffers are willow trees, birch, green ash, red maples, buttonbush, spice bush, some dogwood species, water oak and pin, sycamore, and smooth alder. These and other plants absorb the excess nutrients while also preventing erosion.
Has Doppler radar made tornado forecasting better?
Although predicting tornadoes is still far from a perfect science, Doppler radar used by the NEXRAD system has improved the accuracy of prediction to about 80%, versus about 30% before NEXRAD. Smaller, quickly forming tornadoes are still nearly impossible to anticipate, but larger tornadoes, especially huge tornadoes in the F4 or F5 category range, are being anticipated with much better results. In fact, the National Weather Service is often able to warn nearby residents of a large tornado 20 or more minutes before it actually strikes. NEXRAD can do this by searching for tornadic mesocyclones, which are a good indicator of twisters. Any large tornado vortexes can actually be seen by Doppler radar these days. Thanks to these advances, it is much less likely that a big tornado will take nearby populations completely by surprise. Even a 10 or 20-minute warning can be enough to save dozens or even hundreds of lives.
How big do sunspots get?
Sunspots can range from the relatively small and, except with a telescope, unobservable, to the staggeringly enormous. The biggest sunspots can be more than 100,000 miles, 161,000 kilometers, across. Astronomers measure sunspots in millionths, with each millionth being 1/1,000,000th of the surface area of the Sun that is facing the Earth. The Earth, if it were a sunspot on the surface of the Sun, would be equal to 169 millionths. Compare that with the typical sunspot, which ranges from 300 to 500 millionths, and you get an idea of how big they are. One of the largest sunspots ever measured was seen in 2001 and was 2,400 millionths. But that does not account for how far the solar flares emanating from sunspots shoot out into space. Solar flares can be as long as 100,000 miles, 161,000 kilometers. And some of the energy they emit can literally stretch to Earth's orbit, 93 million miles, 150 million kilometers, away.
What is a neutrino?
A neutrino is a tiny subatomic particle that is far smaller than an atomic nucleus. It has no electrical charge and a tiny mass. Electrons are many thousands of times more massive than neutrinos. And protons and neutrons are many millions of times more massive. Neutrinos are so tiny and ghostly that they almost always pass through any substance in the universe without any interference or reaction.
Can a lightning stroke cause you to burst into flames?
No, being hit by lightning will not make you combust, but it can leave burn marks or singe clothing.
How was the ozone hole discovered?
The famous meteorologist Gordon Miller, born Dobson, 1889 to 1976, was the first to make accurate measurements of the ozone in the 1920s. But it wasn't until 1979 that the depletion of the ozone was observed at the South Pole by the Nimbus 7 satellite. Today, a network of Dobson spectrophotometers have been set up around the world to monitor changes in the ozone.
When do the seasons start and end?
When it comes to climate and weather, the seasons start at different times of year depending on where one is on Earth. Astronomically speaking, though, the first day of spring happens on the vernal equinox. The first day of summer happens on the summer solstice, the first day of fall happens on the autumnal equinox. And the first day of winter happens on the winter solstice. When it comes to official weather statistics, the seasons are considered to be as follows. Winter is December through February, spring is March through May. Summer is June through August, and fall is September through November. So, if you hear a report, for example, that last summer was the hottest on record, that means June 1st through August 31st, and not June 21st through September 21st, which is how it is marked on your typical calendar.
At any one time, how many thunderstorms are occurring?
As astronauts orbiting our planet, especially over the night side, can attest, there are thunderstorms happening all over the place, all the time. On average, scientists believe there are about 2,000 active thunderstorms happening at any given time, day or night. This gives us about 16 million thunderstorms every year.
How do airplanes create clouds?
When the air conditions are right and it's sufficiently moist. The exhaust from airplanes often creates condensation trails, known as contrails. Contrails are narrow lines of clouds that usually evaporate rather quickly. Contrails can turn into cirrus clouds if the air is close to being saturated with water vapor.
What was the first satellite used for monitoring the weather?
The first man-made satellite used to monitor weather conditions was the television and infrared observation satellite TIROS I, which was launched by NASA on April 1, 1960. While the photographs taken were not of the high-resolution standards we see today, they were the first to reveal just how clouds and storms can be remarkably well organized, a fact that surprised meteorologists at the time. TIROS I's other groundbreaking accomplishment was to spot a previously undetected tropical storm near Australia 9 days after its launch. Australians along that country's east coast were thus the first people, thanks to modern technology, to get a heads up that a strong storm was approaching.
How is seawater salinity measured?
The amount of salts in seawater is important because it affects ocean currents, which, in turn, affect the world's climate. Seawater contains a variety of dissolved elements, including chlorine, sodium, magnesium, calcium, sulfur, and potassium. In the past, measurements of salinity were taken simply by going out onto the ocean, filling a bucket with seawater, and testing the salt levels by measuring electrical conductivity. The more salts, the quicker electricity flows through the water because there are more ions present. There are also techniques to measure chlorine or other dissolved elements. More recently, sophisticated equipment has become available for measuring ocean salts remotely. Low-frequency radiometers mounted on C-130 aircraft can scan the ocean during flights, covering over 38 square miles, 100 square kilometers, every hour. The European Space Agency plans to launch its Soil Moisture and Ocean Salinity, SMOS, satellite in 2009 to take readings from space using a two-dimensional interferometric radiometer, a new technology that captures images based on microwave radiation emitted at a frequency of 1.4 GHz, GHz.
What major gases do volcanoes emit?
Volcanic gases contained within the magma, molten rock, are released as they reach the Earth's surface, escaping at the major volcanic opening or from fissures and vents along the side of the volcano. The most prevalent gases are carbon dioxide, CO2, and hydrogen sulfide, H2S. Carbon dioxide is a dangerous gas. It is invisible and odorless, and can kill within minutes. One example in which volcanic gases proved dangerous involved the Dieng volcano complex, or Dieng Plateau, in Java, Indonesia. It consists of 2 volcanoes and over 20 craters and cones, and is noted for its poisonous gas emissions at some craters. In 1979, at least 149 people were killed by poisonous gases as they fled eruptions at 2 of the craters, the Sinala and Sigludung.
What are the most extreme barometer readings ever measured?
On December 29, 2004, a barometer reading of 32.25 inches of mercury was taken at Tonsant Sengal, Mongolia, a world record. At the other extreme, a reading of 25.63 inches was recorded on October 12, 1979, in the Philippines within the eye of Typhoon Tip.
How were the Van Allen belts discovered?
In 1958, the United States launched its first satellite, Explorer 1, into orbit. Among the scientific instruments aboard Explorer 1 was a radiation detector designed by James Van Allen. 1914 to 2006, a professor of physics at the University of Iowa. It was this detector that first discovered the 2 belt-shaped regions of the magnetosphere filled with highly charged particles. These regions were subsequently named the Van Allen belts.
How does the Gulf Stream affect the weather of the British Isles and Scandinavia?
The Gulf Stream currents move warm water in the Atlantic Ocean from the Caribbean Sea northeast to northern Europe and the British Isles. The current flows in this manner because currents heading west from the South Atlantic run into Central America. If North and South America were not connected by this relatively thin strip of land, the current would continue to flow westward and none of the warmer waters would reach Europe. Scotland, Ireland, England, Wales, and the Scandinavian countries would have climates more closely resembling Greenland's. When you look at a world map, you will notice that England, for instance, is at a latitude north of Newfoundland. Logically, it should be a lot colder there than it is, but thanks to the Gulf Stream, England has a climate more like that of New York City than northern Canada. Indeed, mainland Europe is warmer than North America because the Gulf Stream brings warmer weather with it.
What is a bolt from the blue?
This expression relates to the fact that lightning can strike even when there is no rain and the sun has come out. In other words, blue sky may appear overhead, but there may still be lightning generating clouds nearby.